Hello and welcome to the first part of our Rust for Beginners series. In the last part, we installed Rust into our machines and now it's time to learn some basics. So in this video, we will be learning about variables and their mutability, data types, and control flow in Rust. But before, let's take a look at Cargo. Cargo is a package manager and a build system for Rust, and we will be using this tool to manage our Rust projects because it takes care of a lot of our tasks, such as building our code, downloading libraries that our code depends on, and setting up a new project. First, we'll move to a place where we want to create our project. Next, we will do a right click. You will find the open in terminal option. If you do not find this, then you can simply press shift and then click right click. This will give an option of open in PowerShell. You can use this or you can use the regular terminal one. Now a terminal should open up. Inside the terminal, you need to type cargo new and the name of the project. This will create a brand new project for us. Inside the project folder, you can see we have a cargo.toml file. This is the file that keeps track of all our libraries and packages. We will not dive too deep into this. Inside our src folder, we have our main.rs. This is the primary file that gets executed when we run this project. Now it's time to open this project into our VS Code. Now let's open up our main.rs. Inside main.rs, we have a function called main. This is the bootstrap function that gets executed whenever we run our project. Inside this, we also have a printline function. This allows us to print anything into our console. Now let's test run this project and see what we get. To run the project, we need a terminal which is opened at the location of our project, and then we can simply do cargo run. In Rust, there are two keywords that can be used to declare variables. Const is used to declare variables as constants, that is, the variables whose value never change. To declare variable, we first type const, followed by the name of the variable, data type, and finally the data. We can also use let keyword to declare variables, and the variables declared using let keyword are immutable by default, that is, their value cannot be changed. But the difference from const is that we can use mute keyword with let keyword to create mutable variables, that is, variables whose values can be changed. Here are some examples to see what is valid while changing the values of variable. The first example is obviously incorrect as the values of variable declared using const keyword cannot be changed. The second example is also incorrect as the variable is declared using let keyword without mute, which means that the value is immutable. But the third example is correct as we have declared the variable using mute keyword, which means that the variable is mutable and thus the value can be changed. In this example, we can see we have an immutable variable x, and then we are redeclaring a variable called x as x plus 1. Now this is perfectly fine as we are not changing the value of x, rather redeclaring a new variable. Next, we have declared a scope in which we are again changing the value of x. Because of this, the print line will print a different value inside the scope and outside the scope. And when we will run this, we will get this output. First, we need to remove this print line, and then we'll declare a variable a with value 50. And then let's declare a variable b with, let's say, value 59. Don't worry about the data types for now, we'll talk about them later. Next, we'll print these values using print method. We can also use print line. There are two ways to print. First is to pass the variable inside these brackets, or we can do a comma and then pass as a parameter inside the print method. After that, we'll use a third variable to swap the values. Let's say C. We'll make the C equal to A, and now we can swap these values. Since A and B are immutable, we can't really change their values, so first we need to make them mutable. Then we'll do A equal to B, which means we have stored the value of B inside A, and then we'll do B equal to C. Now C had the value of A, so now B has the value of A as well. Finally, let's print these swapped values. And we can clearly see initially the values were 50 and 59, and now they are 59, 50. Let's add some more text to make this easy to read. Okay, now it looks good. We have initial values and then we have swapped values. Now we can make this more efficient by removing C and using some mathematics. Here what we can do is we can set A equal to A plus B, and then B equal to A minus B, and again we'll do A equal to A minus B. This will also result in swap of values. Data types can be divided into two broad categories, primitive and non-primitive. Primitive data types are predefined data types, and non-primitive data types are the data types that have been constructed using the primitive data types. We will dive into non-primitive data types into later videos. For now, we'll be using string for taking input from the user, but we will only focus on primitive data type. Within primitive data types, there are scalar and compound types. Scalar types hold a single value, and there are 4 types within scalar type. The first one is integer. As the name suggests, these hold integer values. These have 2 components. First one is a letter, which is either I or U, representing signed and unsigned values respectively. And the second is the number of bits. The larger the number of bits, the larger the number can be stored. Next we have floating point type. These hold decimal/float values, and these are always signed. These come in 2 types. One is 32-bit and the other one is 64-bit. By default, any decimal values is considered 64-bit. Next we have Boolean types. As the name suggests, these hold only true and false values, and they consume the least amount of space. One variable of Boolean type only takes about 1 bit. And finally we have character types. These can hold any type of character from a regular ASCII to an emoji. Now let's move to compound types, and there are only 2 compound types, i.e. tuples and arrays. Tuples hold heterogeneous data, that is, it is a collection of different types of data, and array hold homogeneous data, which means that it is a collection of same type of data. To declare tuples, after the variable name, we pass data types of each element within a parenthesis. And to declare array, we pass data types of element and then the number of element within brackets. If expressions allow us to execute certain code on the basis of a condition. In if condition, we first have if keyword followed by a condition, and if the condition is true, then the code block for if gets executed. We can also use else keyword in if expressions, and if the if condition fails, then it goes to else. One important thing is that if expression in Rust only deal with booleans, and if any other data type is passed within them, we get an error. We can also use else if to create what we call a ladder. First up, it will check the first condition, which is within if. If it is false, then it will move on to next condition, which is within an else if. And this will continue until all the conditions are false, and then it will go to else. But if any of the condition is true, then only that block is executed and rest of the code is skipped. We can also use if conditions for conditionally assigning data to variables, but when doing this we need to make sure that the data of both the values within the if else block is the same, otherwise we'll get an error as it will take the data type of first code block as default. Match expressions are also very similar to if conditions. We can pass a condition and then execute code based on the condition. In match, we do have some extra options. For example, we don't need to pass just boolean values, we can pass other values, and we can create cases for each value or certain type of values. If we pass a variable as a case, then that is considered the default case, and if none of the case matches, then it goes to the default case. We are checking for even or odd, but if the value is negative, then it will go to the default block. And just like if conditions, we can also use match to assign data to variables. Let's take this code and comment this below our main function. We will be using all of these code which we are doing, so we won't remove them, we'll just comment them and save them for later. Okay, now inside main function, we need to create a mutable string. I know we haven't learned about strings yet, but we will be needing a string to take input from the user. So let's create a new mutable string. Now it's time to take input from the user. We'll use IO to take the input, and keep in mind we have to add this import at the top to use IO. IO stdin dot readline. Inside readline we'll pass and mute a. A is our string variable. And after that we'll do expect for error handling. We'll learn more about error handling in later videos. Let's also print a statement for user to know what to do. So we'll do enter a natural number. Now let's convert this input into an integer. To convert it, we'll first trim the value and then we'll parse it. And finally, we'll do error handling. For that, we'll do expect. Finally, we can do a simple if statement to check if the value is even or odd. So we'll do a %2. If the remainder is 0, then it's even. If the remainder is not 0, that is it's 1, then it's odd. And that's all. We can now run this. So let's open up our terminal. And let's enter 55. And 55 is odd. Now let's try for an even number. And this is working perfectly. Loops are used to execute a set of code multiple times. In Rust, we have 3 types of loops. First up, we have loops declared using loop keyword. These are the most basic loops in Rust. In this example, we can see that we are using loop keyword to simply repeat this print line again and again, And to break out of this, we need to use either a break keyword or we have to use a keyboard interruption. In this example, we have used a continue keyword. Whenever the continue keyword is encountered within a loop, the execution skips the rest of the code and goes back to the beginning of the loop. And we also have a break keyword. And when the break keyword is encountered in the loop, the execution of the loop stops and we go out of the loop. Loop can also be used to assign values, just like if and match. We can break with a value and the value that we pass with the break keyword is returned to be stored into the variable. Next up, we have while loops. These are same as regular loops with just one key difference, that is, we also give a condition for the loop to continue. So in this example, we have given a condition. As long as the condition is true, the loop will continue, and when the condition becomes false, the loop will stop. We can still use continue and break keywords to break out of the loop. We mostly use loops to traverse through arrays and other collections, and for loops are, in my opinion, best for that. In for loops, we use for keyword followed by the name of a variable that will hold the value of each element one by one from the collection, and then in keyword, and finally the collection. In this current example, we are looping through the array, and each iteration will have a different value for our I variable, which will be initially the first element of this array, and then the next element of this array, and then the final element of the array. And when all the iterations are complete, we'll go out of the loop. Let's say a different example doing the same thing. In this example, instead of using an array, we are using a range. We have given a range from 1 to 4, and then we are reversing it. Keep in mind, the last value of the range is not considered a part of the range. First, we'll comment out our old code, which was for odd even. And now first let's create a variable, mutable variable of type U32. And the initial value will be 0, and this is the variable we will be using to find the sum. Next, we have to do the same thing that we did the last time. We'll take an input from the user and convert it to an integer. We have our n, now we need to find the sum till n, and for that we'll use a for loop. We'll run a range inside a for loop from 1 till n. Now if we do 1 to n, then the n won't be included, so we can do n plus 1, or we can use an equal to sign. In this case, n will also be considered. Inside the loop, it's pretty straightforward. We'll do sum plus equal to I. This statement basically means sum equal to sum plus I. And since our sum was 0 at the beginning and I is iterating from 1 till n, all the numbers will be added together inside the sum variable. Finally, we'll print this to console. Okay, so we forgot to add a print line at the beginning, so we'll do that. Enter n. Now let's test it in our console. Let's input 9, and this is giving us sum 45, which is correct. So in this example, we need to find sum of each digit in a number, and the logic is different, but rest of the code is the same. So let me just quickly take the input and create the sum variable.
Okay, now for logic, we'll use a while loop. So we'll do while a is greater than 0. So as long as our number is not 0, we'll add remainder of a divided by 10 into the sum. And then we'll put a equal to a divided by 10. And finally, we'll print the sum. Let's also put a println statement at the top. Let's do 4, 8, 9 here, and this should give us 21. And we are getting 21, which means our program is working just fine. So that's all for this video. Please give a thumbs up and subscribe for more.